In our previous lecture, we have discussed the variation of phase and driving force frequency. Now, today we will discuss the variation of displacement amplitude. Variation of displacement amplitude with driving force frequency. Driving force frequency. So this is our article, that is the variation of amplitude means displacement amplitude A versus omega. So this is a variation A versus omega, A omega graph. We will plot ultimately A omega graph. Now, what is A? A is nothing. A is amplitude of displacement. We know that we have an equation for displacement, that is x is equal to minus iota f naught upon omega zm e raised to power iota omega t minus phi. This is the equation which is complex in nature, but we have already compared its real part, so we will consider only its real part. So, real part of x, that is r, real part of x is f naught upon omega zm into cos of omega t minus phi minus pi by 2. So, this is real part. So, we will consider only the real part of displacement. So, I have already said that we can solve any article with either by real part or by imaginary part. So, in this book, or we will prefer real part. So, this is equation for displacement. This equation, it is also equation for displacement, but in this equation only real part is considered. So, this is also x, real part of x is only x, and this is amplitude, and it is harmonic function. So, if we compare this equation, then the displacement amplitude is this, that is A is equal to f naught over omega zm. So, this is our A. So, this is equation number 1, f naught upon omega zm. It is only z, m for mechanical impedance. So, this is A. Now, this is equation for A is equal to omega f naught upon omega zm. Now, we will discuss its three cases, that is first case at low frequencies, that is omega tends to 0. Second, at high frequencies, very high frequencies, that is omega tends to infinity. And third one is intermediate frequencies, that is resonance frequency. So, we will consider, or we will calculate the three cases at low frequencies, or when omega tends to 0 is omega, and in this equation 1, in this equation omega is appearing in the numerator part, as well as it is also appeared indirectly in the value of Zm. So, first of all, I will discuss when omega tends to 0, what will be the behavior of Zm. Then after that, we will put the value for omega and Zm here and find A. So, here this Zm. First of all, I will discuss Zm. So what is Zm? It is nothing. It is square of R and m omega minus s by omega whole square. This is Zm, impedance. This relation we have discussed in the previous lecture. Zm. So when omega tend to 0, this one 0. So put omega 0 in this equation, you will find that R remain R, m into 0, this term will become 0 and this term will become infinity, because s upon 0 means infinity. So overall, in all these terms, this term is or any finite value, m omega, this will become 0 and it is infinity. So ultimately 0 minus infinity whole square, that is infinity, because square of infinity is infinity. So infinity is there and infinity plus r, again infinity is dominate. So overall, when we see this equation, we will find that this sy omega term will dominate. So this term is dominating. So this term is dominating term. From these three terms, only third term is dominating in this equation. And we may write this impedance as sy omega whole square, ultimately square and under root is cancelled out, and ultimately it will become s by omega. So this is it clear? When omega tend to 0, it is finite value, it has finite value, its value is 0, tend to 0 and its value tend to infinity. Ultimately, from among three terms, this last s by omega will dominate. If it dominate, it means the impact of this term will be applicable in this equation. So Zm is tend to s by omega square under root, that is s by omega. So when omega tend to 0, so this Zm become s by omega. Now we will finally find the value of A. A is f naught upon omega into Zm. That means s by omega. This omega is cancelled with omega and it is f naught by s. So in this equation, in this value of A, it is finite value. It is finite because there is no omega appearing in the equation. So this is our first coordinate, that is, first one is when omega tend to 0, then amplitude become f naught by s. That's finite. It's a finite value. And second, we will discuss of second equation. When omega tends to infinity, infinity is very large at very high frequencies. When omega tend to infinity, then first of all we have to find what will be the value of Zm. You know Zm is r square plus m omega minus s by omega whole square. So put the value of omega as infinity on the right hand side. You will find that this is finite and m into infinity means infinity. S over infinity means 0. So this term will become 0. This is finite, but this term is infinite. Means among three terms, this m by m into omega will dominate. So overall, we will consider only m omega square under root, that is Zm tends to m omega. Is it clear? So Zm become m omega. So put the value in Zm in this equation, first equation, and we will get the equation 1 become f naught upon omega into Zm. Zm means m omega. So ultimately it is f naught upon m omega square. Now omega is appearing in this equation. So at last we will put as omega tends to infinity. So this something upon infinity becomes 0. It means this amplitude tends to 0. So this is second point. When omega tends to infinity, then A tends to 0. because infinity, putting the value of omega as infinity here, so f naught upon m into infinity square. So infinity square is again infinity, because square of infinite term is infinite. So it will become infinity, something upon infinity is 0. Therefore, second point is omega tend to infinity, a tends to 0. This is second part. And third case, when omega is resonance or omega has intermediate values, that is, it is called resonance condition. So what is resonance? You know that at resonance this amplitude is maximum. You know that at resonance, so you have something in the lower classes you have studied that this is the graph, and this highest value is called maximum value, and the corresponding frequency is called resonance frequency. So this is that frequency, the frequency at which amplitude become maximum. If amplitude is maximum, then this is maximum, f naught over omega Zm is maximum because it is value of a. Or you can say that this is maximum, so something upon minimum is maximum. So we can say that, or omega into Zm is minimum. Okay. We can derive this a is maximum, or we can say that omega Zm is minimum, because the denominator part should be minimum. So omega Zm is minimum. So if omega Zm is minimum, then we will take the derivative of this equation on both sides. So on differentiating, we will get the derivative of omega Zm over omega is 0, because the derivative of minimum term is 0, because maximum or minimum both are constant in terms of mathematics. So it will become 0, and it is d omega of omega Zm. So we will do the derivative of this equation. So what is Zm? You know that Zm is under root of r square plus omega m minus s by omega whole square. So let me put here, and you will get d omega of omega into square root of r square plus m omega minus s by omega whole square. This is. Now you can find the derivative of this equation. So there are two functions, first and second. So you have to apply the formula of derivative of two functions, derivative of x into y. So you have to take derivative first as it is derivative of second, plus second as it is derivative of first. You can find this derivative by yourself, and on solving you will get the omega, value omega is equal to square root of s by m minus r square by 2m square. So you can find this value yourself, because it is simple derivative. First into second, there are two functions, you can find the derivative of two functions, and at last on solving you will get this value omega. So this is the frequency at which amplitude become maximum. So this is called resonance frequency. Resonance frequency. That is, this omega is equal to this one. Here omega tend to 0, omega is infinity, and here omega is this, s by m minus r square by 2m square. Or you can say that it is omega dash, or we can say that it's omega dash or omega dash. I will not use omega dash, it's omega double dash, because we have used omega dash as the frequency of damped oscillator. So it is omega double dash. Let it be say. So at this frequency, amplitude is, so what is amplitude? Amplitude become minimum, and that is f naught upon omega r. So this r, Zm become r, because when you put this value of omega, this value here, and you will find that this Zm become R. You can solve that. Zm is this one, R square plus m omega minus s omega whole square. And when you put the value of omega here, omega here, omega here, and you will find that on solving, these both terms will cancel out, and R square under root is R. So Zm become R. Therefore, A become F naught upon omega R. So A become F naught upon omega into R. So these are the 3 points from which we can trace or plot a graph between amplitude and frequency. The first point, omega 0, A finite, omega infinity, A is 0, omega double dash, A this one. So we can find, or we can plot the graph between amplitude and frequency. So omega has 3 values, omega tend to 0, this is omega double dash, omega infinity, it is omega double dash, it is 0, this one. And the 3 values of A is 0, A is F naught by S, A is 0, it is F naught by S, and it is F naught by omega R. It is greater than this one is greater. So this is F naught upon omega R. Okay. So plot when omega is 0, A finite, omega 0, A finite, first point. Omega infinity, A is 0, omega infinity, A become 0, second point. First point, second point, and third point, when omega is omega double dash, this one, omega double dash, A become this finite, A become this corresponding here, finite. Okay, this one. Or you can plot the graph. The graph is curved in nature, and its nature become this, like this. So it is graph which start from a finite value, there is some finite value, start from its finite value and ends at 0 value. So it will touch the x-axis at infinity. So this is the nature of graph between amplitude and frequency omega. Similarly, we can find the other variations like this. We will discuss 3 cases and we will find the variation of velocity, acceleration and other phases also. Thank you very much.